Hi, welcome to our math. Today I'm doing a series of videos on exponential equations and solving them. So these four have an interesting twist that we have two bases that are different that each have an exponent. And the way I'm going to solve this is, because this is multiplication, I'm going to divide by 5 to the x on both sides. On the left-hand side, I'm going to end up with 15 divided by 5 to the x equals 761. Which is 3 to the x, equaling 761. At this point, I have a couple of ways I can solve it. So for this first one, what I'm going to do is I'm going to rewrite this logarithmically. A log is an exponent, so I'm going to say the exponent equals a log. Because exponents are logs, exponent equals log. The base of the log is the same as the base of the exponent, so log base 3 of 761. Well, you don't have a log base 3 button in your calculator. You just don't. Well, you might. There are some people who have change of base buttons, but most calculators don't. So the way we solve this is we rewrite this as log of 761, the argument, divided by log of 3, the base. If we do log of the argument over log of the base, then we will get that, and we'll write it up here, x equals 6.0391. We then need to go back to the directions and find out what we need to round to, and it says round to 3 decimal places. So x is equal to 6.039, rounding correctly. All right, I said I would do these differently, and I will. I'm going to divide both sides by 13 to the x. So again, I have 9 divided by 13 to the x equals 3,500. What I'm going to do this time is, instead of rewriting it logarithmically, I'm going to take the log of both sides. I'm going to say log of 9/13 to the x equals log of 3,500. The thing about logs is they're exponents, once again, and when a log's argument has an exponent, the exponent can be brought out front as a multiplier. So I can say x times log of 9/13 equals log of 3,500, and then if I divide by that log of 9/13, I want you to notice that if I had written this one logarithmically, I would have ended up with a log on both sides, and I would have divided by log of 3. I'm really doing the same exact motions regardless of if I write it logarithmically or if I take the log of both sides. The calculations that you throw into your calculator will be the same either way. For this one, I'm going to get that x is equal to negative 22.1919. Once again, we're rounding to 3 decimal places, so x is going to equal a negative 22.192. All right. Now this next one looks a little bit different. What I need to do here is I have to remember that a to the n times a to the m is equal to a to the n plus m. But what I want to do is I want to go backwards. If you're adding two things in the exponent, it's the same as multiplying the bases. So this is going to be rewritten 11 to the x equals 26 to the x times 26 to the negative 2. Okay, so that's our big rule that we want to follow. Now everything is going to be the same. 26 to the x, 26 to the x, 11 divided by 26 to the x equals 26 to the negative 2. I'm going to take the log of both sides, so that x times log of 11 over 26 equals log of 26 to the negative 2. Divide by log of 11 over 26. And x is going to equal 7.5751. And when we round this to 3 decimal places, we get 7.575. So this one, it's going to be mostly the same thing. We have one extra number in this one. 27 to the x equals 243 times 9 to the x times 9 squared. I'm going to divide 9 to the x from both sides. 27 divided by 9 is 3, so I have 3 to the x equals, and it equals 243 times 81. So if I take the log of both sides, this becomes x times log of 3 equals, well, 243 times 81 is going to be 19,683. And then I'll divide by log of 3. And I'll get that x is equal to 9. If you know your powers of 3, this is 3 to the 5th, this is 3 to the 4th, 3 to the 5th, 3 to the 4th means our exponent is 9. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks!